Everyone, welcome to new session on machine learning. Today we are going to see about measure of spread. So in last session we have seen about measure of frequency and measure of central tendency. So in this video we'll define about measure of spread and why we are going for measure of spread. Okay, so this describes how similar or varied the observed values are within the data set. Okay, so measure of spread can be calculated using range, quartiles, interquartile range, and variance and standard deviation. Okay, measure of spread can also be visualized using the histogram. So how the data are spread. So these can be visualized using histograms. So this is called as measure of spread. Okay. So why we are going for measure of spread? See, this is the data set 1 and data set 2. What is the mean of these two data sets? The mean of these two data sets are same, 6. Okay, so these two data sets have the same mean, but notice how the values in data 1 vary in the way different from those in data set 2. Obviously, the composition of the two data sets is different despite the fact they both have a mean of value 6. Okay, the critical point of difference here is the range. Okay, now we can calculate range, that is a part and measure of spread, or we can calculate something quartiles or interquartile range, variance on standard deviations. Okay, so what is mean by range? So this is the measure of spread. So what is mean by range? The range of two data set, which is a simple measurement of a data variance. Range is calculated by subtracting the lowest single value from the largest single value. Okay, so the range here for this data set is 8. I guess you have understood. So what is mean by quartile? So quartile is, if you have some data set, then you have to arrange it in the ascending order, and then you have to calculate quartile. How you will calculate the quartile? Cut the order data into 4 parts. You can get into 4 parts, or you can cut into 5 or 10. That depends upon your choice. But cut into 4 parts. So first part is quartile 1, second part is quartile 2, and third part is quartile 3. Second part is also called as median. Okay, then what is mean by interquartile range? So interquartile range is Q3, quartile 3 minus quartile 1. So that is what I have calculated. This is interquartile range. And the last two is variance and standard deviation, which you have come across so many times. So the average of the square difference from the mean is a variance, and the standard deviation is a measure of how spread out the number. This is square root of variance is a standard deviation. So unit of variance is squared units, and unit of standard deviation is mean. This you will understand in the next slide. Okay, why I have mentioned the units. Okay, and coming to range, a weakness of this measure, there is a weakness in this measure. Weakness of this measure is the fact that one data point can significantly inflate the range of data set. That is, if the data set is 20, see, suppose here 20, then obviously here 20 minus 2, which is 18. So this may be inflate the one point, that is significantly inflate the range of data set. So this one point may affect the whole data set range. Okay, so while measuring the range, the data set can be usually bound, right? This technique is susceptible to anomalies. Okay, this range, quartile, interquartile range are sometimes, these both quartile and interquartile range are sometimes susceptible to anomalies. Okay, a practical alternative and a good way for measure of this what is this measure of spread is variance and standard deviation. And all the time variance and standard deviations cannot be used. Okay, we'll use most of the time standard deviation. So why the standard deviation? Variance of a data set measures the mathematical dispersion of the data relative to the mean. Okay, however, though this value is theoretically correct, this variance value is theoretically correct, it is difficult to apply in the real world, as I mentioned, because it is in the squared units. Okay, the value used to calculate it was squared. The standard deviation as the square root of the variance, it is the square root of the variance, gives a value that is in the same unit as the original value, which makes it easier to work with and easier to interpret in conjunction with the concept of normal curve. Okay, so it is best to choose the standard deviation. So comparatively, range have more susceptibilities, and quartile sometimes can be used. Quartile and interquartile range also have susceptibilities, whereas in variance and standard deviation, they both are same. Of course, the units with the comparatively with the units, we use mostly with the standard deviation for real world applications. Okay, I have given a simple data set 1, data set 2, data set 3. See, this all has a mean, same mean, and this too has a range, same range. Okay, so see here I have calculated quartile, interquartile, variance. So how to calculate this quartile, interquartile, I have mentioned in the previous slides. Okay, this is how to calculate the quartile, this is how to calculate the interquartile, and then variance, and then standard deviation. So variance, this is the formula, and standard deviation square root of variance. Okay, so I have calculated all these things. Okay, so if you see, as we concluded, standard deviation a good measure of variability. So a standard deviation measures variability by calculating the average square distance of all the data observation from the mean of the data set. Okay, so this is the mean of the data, x bar is the mean of the data, this is each data set, and this is 1 n by n, total number of data divided by minus 1. Okay, so when this metric is lower in number, says the standard deviation value is lower in number relative to the mean of the data set. Okay, just compare. If there is no data set 2 and 3, then you have to compare the standard deviation with the mean. Okay, so if that when this metric is lower in number relative to the mean of the data set, it indicates that most of the data values are clustered together. See here, these most of the data values are clustered together. Okay, whereas the higher value, see here, this is the higher value, indicates a high level of variation spread. So see here, high level of variation spread. Okay, so depending upon the standard deviation values, we can tell how the data spreads are. Okay, so if there is data set 1, 2, 3, then we can compare using data set 1, 2 and 3. If it is only data set 1, then we can compare the standard deviation with the mean. If the mean is higher than the standard deviation, then the data set is clustered together. If the standard deviation is high, then data set is somewhat what is a high spread across. Okay, so that's all for the today's lesson. Let us meet in the next session with the continuation in the measure of spread. So in the next session, we'll see about the pictures, how to visualize this measure of spread. Okay, till then, take care. Bye bye.